Welcome to Math 2320, Section 8.1, where we look at systems of differential equations in terms of matrices. So here we have our system of first order differential equations. And so we want to write this as a matrix. So looking at it in terms of a matrix, I can write the derivatives as this column vector. So 2 rows, 1 column. So here's x prime. If you grab off all of the coefficients here, 5, -3, 9, and 4, that's done by matrix multiplication times x and y, our two functions. There is no driving part, so the b part on the end is 0. So really just a question of bookkeeping here and finding all the terms. Alright, so we do this same thing for 3 equations and 3 unknowns. So just again recognizing it as a matrix. So we've got our 3 by 1 here for x prime. I've got all of the coefficients for matrix A here, -3, 7, -9, 2, -1, there's no z terms, so 0, 10, 7, and 3, x, y, and z, and the b part on the end is 0, 0, 0. Alright, so in question 3 here, they want us to put it back. So if we have it in this particular form, so here's my matrix AX. I've got this driving function on the right hand side. So I simply just use the coefficient 6x, 5y, -9z, so got that, 0 e to the 5t, -7e to the -2t. And so I do that for each of the rows here all the way across, putting it back in the system of differential equations. Now I wrote it with the zeros just so that you could see it, but we don't really need to put them there. And so that would be what our system would look like back in our normal format. Alright, in question 4 here, we have our differential equation with our system. They're claiming that this is a solution. So that says x of t is e to the -2t and y is also e to the -2t. My matrix A is just the coefficients 3, -5, 5, and 7. So that's what would go in here. And so let's look at what is the derivative for each one of these. Well, the derivative is -2 e to the -2t for both of them. And so if I look down here, what is a times x? So here's a. Here is my solution. All right. And so I simply multiply 3 times this first term -5 times that term. 5 times e to the -2t -7 e to the -2t. And I get -2 e to the -2t. And this is supposed to be, which it is, what we found for dx dt and dy dt. So not things too difficult in section 8.1. Again, it's just a question of bookkeeping. In question 5, we're looking to see, are these two functions linearly independent or not? And so to figure that out, I look at the Wronskian. I put the two functions that were given to us. So you see I've got 1 e to the -6t and 1 1 e to the -9t. I put those in our columns of our matrix, and then I'm going to find the determinant, so downward diagonal minus the upward one. When you multiply these exponentials together, the exponents add, and so I get e to the minus 15t, another e to the minus 15t, so a minus 2e to the minus 15t, and that's not 0 for all t. Now, why is that the case? Well, you have a negative exponential, and this negative exponential, even though it is decaying, it never is exactly 0. So yes, these two functions are linearly independent.